Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at sets. So sets are just collections of objects. In our topic here of probability, we'll see them as collections of possible outcomes when we perform some random event. So we're going to start with this notation. This is the Greek letter epsilon. It refers to the universal set. So here in this question, the universal set is the integers 1 to 60 inclusive. So that means basically in this question, I'm only considering the integers, i.e. whole numbers, between and including 1 and 60. So if I want to write epsilon here as a proper set, we always use these squiggly brackets to denote a set. So it includes the options 1, 2, 3, all the way to 60. I'll just use dots. It'll be tedious to write out all the numbers. So each of these individual possibilities is called an element of the set. So the set epsilon has 60 elements. There are 60 things, 60 objects inside this set. So these lines here just mean the number or cardinality of the set. It's just how many elements are in the set. So A and B are going to be subsets of epsilon. A is going to be the set of multiples of 10. Now, of course, there are infinitely many multiples of 10, but in this question, we're only considering integers 1 to 60, so I don't need to write that many. So to write set A, again, I need squiggly brackets. I'll only include the multiples of 10 up to and including 60. So 30, 40, 50, and 60. So you can see that A has 6 elements. So we write it like this. Number of elements in A is 6. So B is the multiples of 15. Once again, we only need to go up to 60 because that is our universal set. So B includes the elements 15, 30, 45, and 60. So you can see very clearly that B has 4 elements. So we write it like this. Okay, how many elements would be in this set? Well, hopefully you already know this little dash here means complement. It's complement with an E, so it doesn't mean like I'm saying something nice about you. Complement with an E basically means goes together. It goes together with A. So reading this symbol as not, this is saying how many elements are not in A. Well, there's actually quite a few of them. So we're not going to write out the set not A or A complement. That'll take too long. These lines just mean I need to say how many are not in A. In other words, how many numbers from this universal set are not in A? Well, there are 60 in the universal set. There are 6 in A, so the number not in A must be 60 minus 6, which is 54. So this notation here means intersection. Read it as and. So read this as A and B. We are asked here for the number of elements that are in A and also in B. So let's actually write out this set. So if there are no lines here, we have to write a set. So we'll use squiggly brackets. So the 2 elements that are in both A and B are 30 and 60. So that means that the number in A and B is 2. So this symbol here means union. Read it as or. So here we're looking at elements that are in A or B, and it includes those that are in both. So really this means A or B or both. So if I want to write out this set, again, no lines means I have to write a set. I need squiggly brackets. I'm going to include everything in A and everything in B. But I don't want to write elements twice. You can see here I've written 30 and 60 twice. So I'm going to rub out one of the 30s and one of the 60s. So when you're writing the elements of a set, each of these should be different. So now we can see, if we just count them, there are 8 elements in either A or B or both. We don't double count those that are in both. We don't count them twice. So this here says we want to find the number of elements that are in A and not B. In other words, we want to find the elements that are in A only. So this will include the elements of A. So we already know that's 10 to 60. But we need to get rid of those that are in B. So 30 and 60 again, they are in B. So I will rub them out. So left are the elements that appear in the A list, but not in the B list. So there are 4, and so the number in A and not B is 4. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.